So we have here Paul Ivanov and Thomas Kluyer of IPython. Now, IPython I think of as sort of being the cool kid in the room. I was looking on GitHub recently. You guys have like 3,600 stars. Is that roughly correct?
How do we cash those in?
Yeah. So can you name any project that has more stars in Python?
Django?
Probably Django.
Maybe Django. I was thinking that I looked. Pandas was very close. Pandas had about 3,000. Yeah. But they're going to talk today about the backend, or about the protocols and backend of IPython. When did the new system come out? Was it 07, 08, the sort of the sane system?
I think 2011.
Yeah. The protocol system with the separation between frontends and kernels was 0.11.
Okay.
That was in about 2011. But
and since then, we've seen a number of products come out. The IPython Notebook has been very popular, but there's sort of magic behind the magic. And I guess we're learning about that today. So let's welcome Paul and Thomas.
Thank you, Matt. So I'm Paul Ivanov. Thomas and I are both at UC Berkeley. We're both core IPython developers. And we want to tell you a little bit about the IPython protocol. If you want the resources, like this is an IPython notebook that I'm running, and that's at this URL down here, IPython/front to back. And I just wanted to show you that this is a live notebook, so this is dangerous, right? We are gonna do some live coding. All right, so the first thing about this talk is that we are talking together, but I'm gonna go first, and then Thomas is gonna go after me. But it's one talk, and for those of you that know both Thomas and I, you have to probably say that I'm the bigger ass, but I'm going first. So that's that. So what is IPython? I guess at PyData, it's been said you don't need to introduce what IPython is, but I just wanted to put up into a little cloud what all the sort of pieces of IPython. And the reason that I want to do that is I want to sort of outline what the things that we will talk about and what the things we won't talk about, right? So, but before that, sort of what the punchline of the talk is. So this is your one chance to tune in and get something from this talk. It's that if you implement any one of these pieces, you get access to the other pieces for free, right? So that's the big deal, is that we've decoupled things so that you can only work on the piece that you really care about and get the benefits of the other things in the IPython project. So, and it's all BSD licensed. So this talk, all the stuff that's in that blue cloud is out of scope. The notebook is only sort of half covered, right? And we're going to talk about the kernel, and Thomas is going to talk about the kernel and kernels. That should have been plural. And then I'll talk about the front ends. OK, so there's an analogy here. It's imperfect, but it's useful. And that's the analogy of the web. So on the web, you have a web browser on the left, and it speaks HTTP to a web server, right? So that's sort of pretty standard. On the IPython, we have slightly different language. It's a client-server relationship. Tim Berners-Lee kept the server, changed the client name to browser. We kept the client name, changed the server name to kernel. And the way the client and the kernel talk to each other is what I'm going to call ICCP for the purposes of this talk. What's ICCP? Well, it's the Interactive Computing Communications Protocol. I wanted the IPython protocol. IP was taken. I don't. That usually gets a bigger laugh. It's the first time I'm giving this talk, but that usually gets a bigger laugh. Interactive Computing Protocol, ICP, was also taken by some clowns, and the Internet Cache Protocol. OK, so ICCP is what I'm going to call it. OK, so we have different pieces here. You have the kernel, which is the computational engine, right? That's the server part. It accepts messages. It performs actions on behalf of the user, of the client, and then it sends the results back out. OK. And there's a one-to-many relationship between kernel and clients. So a kernel can have multiple clients, just like a web server can be serving multiple web browsers at a given time. And so you could have a regular console connection, a Qt console, a vim-ipython, another vim-ipython, and a bipython, all connected to this kernel right here. And the space between them is left blank for the purposes of just saying that there is a messaging protocol here. And we're not going to cover it in detail, but just sort of give you enough of the flavor to make you feel comfortable that this is something that, should you want to, you can actually go home and read up on a little bit and implement pretty quickly. And then get the benefit of the rest of the ecosystem. OK, so the messages that are exchanged back and forth consist of a header, which has a message ID, a message type. It references a parent header if it's a reply to something, and then it has content, where the content sort of depends on what the message type is. So an execute request might have the code that you want to send, right? As a client, you make an execute request, and then the kernel may give you an execute reply that may be, say, OK, I did that, and here are the things that you wanted, or give you an error and saying, here's your traceback, here's where the problem is. OK? So this isn't all there is to it, but these are sort of the main core parts of it. OK, the client connects to exactly one kernel. That's the way we have it right now. It sends messages to the kernel on user actions, and its job is to display the kernel messages when it's appropriate. So it turns out that the client will receive all messages that the kernel sends it, but the clients that we ship in IPython right now only hang on to and display the messages that they generated, that were replies to their actions. So there may be other messages that they're hearing, but they're just sort of letting them drop. They're letting them fall on the ground. They don't care, right? That doesn't have to be that way, but that's just the way it is right now. And for example, in vim-ipython and bipython, I don't do that. I capture all messages and I display all messages to the user because it's sort of, that may be what you want. That may be useful. Why would you want to have many clients? Well, you have differences in, for example, the first client that we had is the Qt console. That's the first separation. And what we got with that is the ability to edit, like in a sane manner, multi-line input, right? We weren't slave to read line anymore, and you could actually have, in a Qt environment, you can have rich syntax highlighting, right away, and you could have multi-line editing. You could also display images, it turns out, in Qt console. So display capabilities in the Qt console are better than they are in the terminal. And in the notebook, they're even better, right? Because you can embed video, you can embed JavaScript. You guys know this stuff. Another reason is that there's a difference in persistence. So you can't save and rerun parts of the console and the Qt console code that you've written and executed. That's not the case if you use the notebook, because everything that you've wanted to save, you saved in the IPython file. It's also not true in vim-ipython, because you were just working in a Python file and sending code and getting the results back in line. And so the work that you did is actually saved. Also, you may have a preference for the command line interface. So I have a chronic CLI problem. It's terminal. And then you may have different client-side requirements. So the Python is required if you want to use the things that we ship out of the box, except for the notebook. The notebook requires a modern browser. That may not be something that fits in your environment, and you still want to use the IPython machinery. So you may need to write your own client that is on the JVM or that is on some other platform. OK, so clients that ship with IPython is the Qt console and the IPython console. And when you launch either of those two commands, you're actually launching two things. You're launching the kernel and the client at the same time. If you want to launch just the client to connect to a kernel that is already existing, for example, maybe a notebook started up a kernel for you, you can just pass the existing flag, and then that won't start a new kernel, and you can just connect to a kernel that's already there. OK? So the third-party ones that I'm going to talk about are vim-ipython and bipython. How am I doing on time? I didn't. Here you go. OK, we're good. OK, so vim-ipython was a plugin that I wrote for Vim with Minreg and Kelly's help at SciPy 2011 sprints. We can do a live demo. And here I outlined a little public service announcement for Mac users. OK, so I really like this quote. I have randomly generated quotes when I log into a shell, and I found this one so that you guys could all read it. That's Donald Knuth. OK, so how does vim-ipython work? Well, I have over here, this is a live notebook. So let's prove to you that it's live and saying x equals hi py woo data live coding. All right. What is the value of x? OK, it's hi py data. And that it's really IPython. Let's say that y is equal to, let's run a shell command, date. OK? So what is y? OK, it's Saturday, May 3rd. This is when we're giving the talk. Good. I'm going to switch over here, and I'm going to start up Vim and just a random Python file. It's empty. There's nothing here right now. And I'm just going to launch a Vim command, IPython. OK, so that's a command that I provide in vim-ipython. What this gets me is the ability to now say, oh, live demos. All right. If I say print hello here, oh, come on. Print hello. All right, there we go. Good. OK, so I've just sent that over. And so what is x? Can I get the results from x? If I do x here, x is hi py data, y is Saturday that. I can also get text completion, a tab completion rather. So you don't use a tab in Vim for that sort of thing. But here are the things that x can do. X was a string. And so maybe I forgot, how does find work? Well, what if I do double question mark? That gets me the doc string. So I'm still in Vim, but I'm getting the output of that IPython sends along, the introspection stuff for free. OK, and on the kernel that was already open. So that's vim-ipython. All right. Next is bipython. Bipython is a new project that I've worked about 2.5, maybe 3 days on a month ago. So it's actually, its month anniversary was yesterday. So let's 3 cheers for bipython. Bipython, let's do the live demo for that. So let me quit out of here. I don't care to save. So what bipython gets you is that it uses this. You'll notice it took up the whole screen. OK, so it actually uses Erwid. So as I start typing, I don't have to type tab. It actually gives me completions right away. So if I import this, and if I do this dot, here are the things that this can do. And as I tab through them, unlike in GNU read line, it'll just give me the options, right? And you have to type them out explicitly. Here, I can tab through them and see the doc string for it. OK? And then moreover, if I execute something over here, like print, I'm running out of time. Sorry, Thomas. If I do that here, I have to press a key. There's no event loop here. I have to press a key. But as soon as I do, then it prints out the thing that went over the wire, over the protocol, and we got it back. OK? So that's that. Embed is your friend here. So there's IPython. You can import IPython and call IPython.embed in any of your Python code to get an interactive Python prompt, a single console, the single good old classic IPython that you get if you just type in IPython. If you type in embed under kernel, that will get you a string like this. And I'm not going to demo it here so that Thomas has enough time to do his demos. But basically, it allows you to use any of the clients that I just covered to hook into your Python process wherever it is that you made that embed. So think of embed as being a set trace, but on steroids, right? Or I don't know what's more than steroids, but it's sort of on steroids and Red Bull and whatever else you want to throw at it. OK? So the takeaway from clients is that your favorite tool can talk bidirectionally to Python. That's the takeaway from that. And I'll let Thomas take over. He's number 1.
As Paul says, I'm number 1. So Paul's very neatly handed over with half of our time, leaving time for questions. So I'm going to talk about the other half of the equation, which is the backends. So this protocol, this protocol system and the decoupling of backends and frontends was originally designed so that we could have multiple different interfaces that you were using to talk to the same code, and we've got several of those, as Paul showed, but it quickly became apparent that, in a sense, what was even more useful with this was the ability to write different backends. And the protocol is all specified in 0MQ and JSON, which are language-independent things. It's not like, it doesn't use Python's pickle or anything. So there's nothing, well, there are a few Python-specific bits in it at the moment, which we're kind of weeding out, but it's perfectly possible to kind of work around those and implement the protocol for other languages. So one of the first communities to do this seriously was the Julia community. And Julia is a very new upcoming language for scientific computing. It has optional type annotations that let it compile code for better performance. And they had plans to write a notebook interface similar to IPython. And when they realized that you could just implement a kernel for IPython, they decided that they'd do that and make IPython in its iJulia flavor their main interface. So I can switch over to, I've actually set up all of these systems on my laptop for the demo. So this is an IPython notebook running Julia code. So you can see this is the very first time I'm executing with no imports, and it already knows about sign functions. You can see there's Julia's syntax for for loops and things. Syntax highlighting doesn't seem to be working here. I'm not quite sure why that is. But they implement the same. So this is something they have to implement independently. These in and out are something that are implemented in the kernel. They've taken the same notion, so you can do out bracket square brackets 2 is the result from the second executed cell. They've got some nice functionality for working with matrices, and it doesn't look so good on the small resolution, but you can see there they've got this nice. They've integrated nicely with the display machinery, so you can do nice Unicode display and things. The little dots breaking up the matrix are Unicode things. They've also implemented the tab completion. So I press tab there to get the list of different options. And if I press shift tab, the introspection thing, and that's our bug, not theirs, the fact that that tooltip has flown off to the bottom of the screen. But if I create it again, so Julia has multiple overloaded implementations of the same function depending on what you pass to it. So that's what they show when you try to introspect something, all the different things that you could pass into it. So this is Julia is very much the most mature and best developed kernel other than the IPython kernel that we maintain ourselves. And they also have integration, another kind of integration with Python, which is they have a way of wrapping Python libraries into Julia. So this is using their pycall package, and it's actually loaded the Python scipy.optimize method, and it's passing the Julia equivalent of a lambda into a Python function, and that's all working perfectly. And pyplot is a wrapper around matplotlib to run it with Julia native syntax. So it takes a few seconds, but that's a matplotlib plot generated entirely from Julia code. And you can see it says pyobject matplotlib, da-da-da. And as the display of that plot probably hints, they've also implemented all of the multimedia display. So this is this line of code is partly hidden due to another of our bugs, but you can see that we're just displaying raw text as HTML there, and you can do cleverer integration with Julia. We've defined a function which defined a type which knows how to display itself as HTML. So yeah, that was Julia. So then a few weeks ago, I was invited to go and take part in a hackathon at our OpenSci, and I just found out today that they've actually put a picture from the hackathon on the website, and that would be me sitting in the background. So thankfully I was wearing a clean shirt that day. And so after a couple of days, I had a working implementation of an R kernel. So you can have, this is another IPython notebook talking to a different kernel. Now it's running R code. And again, this looks slightly nicer on a larger screen size. And again, R has the implementation of plotting. This time it's using R native plots, and that's saved to a PNG and then sent to the notebook front end, so you can get your plots in line as you want. There's I made a separate package, IR display, which handles the rich display functions. And the idea of that is that we've also got a R cell magic inside the IPython kernel, so that you can mix Python code and R code. And we wanted it to be possible to use the same display mechanism, whether you're in the native R kernel or in the IPython R cell magic. And that will be possible. The part of the R magic that would integrate with that isn't implemented yet, but I plan to get to that. And straight away, within a few days of the hackathon where I implemented this, Ramnath, I won't try to pronounce his last name, was at the hackathon and very enthusiastic about this. So he straight away started using it with his R maps library. So that's just defining a bit of boilerplate, and then we can display, and this is using HTML to display a JavaScript map thing, so this is fully interactive in the notebook. And that integrates with R computations, so we're providing some waypoints in an R list here. And when we add that information to the map, the JavaScript can pick a route between them. And so that's a relatively new thing, but already starting to see keen use. And just to demonstrate that, those are kind of good examples of using this in a scientific computing context, which is really kind of the space we're aiming for. But it's not in any way limited to languages that follow a particular paradigm. So Haskell, if you've not used it, is a functional language that uses a very, very different paradigm and a very different syntax from Python or R or Julia. And these simple things will look much the same. The first one always takes a little while. But we're rapidly getting into things that I won't pretend I understand. But look, it's clever Haskell stuff. Yeah, I didn't actually write that what's going on cell, but seems quite accurate. And it's doing some rich output there. It also integrates with our little, what we call the pager, which is the panel that pops up at the bottom here to display help. And yeah, that's demonstrating that output comes in live as you're running the computation. It doesn't all wait until the end. Here's the rich display machinery, hopefully, yes. So you can, this is using HTML to display objects in different ways. And again, I won't claim to understand how the Haskell is doing that, but it is. There's some more different display things, including, so there's some custom stuff in the front end that iHaskell adds. So things that it doesn't know how to display come up with this button, and you click it and it shows you what the error was when it tried to display it. It also integrates with a Haskell static analysis tool so that it will complain about, you've done your code like this, you could do it like this, which I imagine, and there's a way to turn that off if it gets annoying. There's another integration. This is the Haskell equivalent of doc strings. So this is probably the third most well-developed kernel after Python and Julia. This is showing different methods, and yeah. So then a couple more things I just want to quickly show. So I've done my demos. So I've demonstrated 3 of the kernels, and you've of course seen the Python kernel, which is what you're normally running when you run IPython. We have kernels at some level of development in all of these languages. That may be pretty basic. I wrote the Go kernel to try and learn Go, and I wouldn't recommend anyone uses it because it doesn't work very well.
Don't go using it.
Thanks, Paul. There's a fascinating one called Calico, which runs on, I think it's the .NET virtual machine, and lets you like switch between different languages. Is doing all sorts of crazy things. There's a Scala backend and a Camel backend, F#, Erlang. Yeah, and that's just, you know, most of these the IPython team is not involved in. We've just, you know, I worked on Go, and our Mins helped with the Ruby kernel, but most of them are people who've just read our docs, maybe asked us a few questions, and gone away and implemented it themselves. So we think that's a really good testament to how well this protocol works. And we're talking to all of those communities in designing new versions of the protocol and the notebook format and everything. So yeah, I should have said that one of the things you get for free when you implement a kernel is that that's like the code execution is completely separate from all the notebook saving and loading stuff. So you get all of our machinery to store the code and the notes and the results of that in the notebook without having to do anything else. And a quick sneak preview of for IPython 3.0. So at the moment you have to, to use the notebook with an R kernel, you have to give it this long command line, IPython notebook, kernel manager, kernel command equals, and then a list of arguments to pass to start an R kernel. In IPython 3, there's going to be a way for kernels to kind of register themselves. So there'll be a directory with a list of kernels, and IPython will introspect that. So when you create a new notebook, you'll be able to just click on a drop down and say, this notebook is going to be running R code or Julia code or Haskell code or any of the other languages. And this is the little spec file that the R kernel will install something like this on your system, and this tells IPython to start R and call this function. And this is already sufficiently implemented that in IPython, in the development version of IPython now, you can start the console, not the notebook yet, but the console or the Qt console with this -- kernel flag, and I've got the IR file installed on my system, so I can, yes, it works, good. And okay, exit doesn't work yet. Never mind, I can quit like that. And I can even, you'll also be able to go between, so this is now going to be the front end running in Python 2, so you can see it says Python 2 up at the top there, but if I print sys.version, that's Python 3. So that's a brief sneak preview of what will be coming in the next version of IPython, this integration so that it knows about different types of kernel. And that's the end of what I've got to talk about, so that's just the right time to open it up for questions.
Hi. First of all, I'm a big fan of IPython, and I advocate it often and vigorously to people when I meet them.
Thank you.
Thank you so much for this work. So I'm a little dismayed at this trend of trying to throw every ever more complex JavaScript library into a cell in IPython. Is there some way that you could manage expectations or put a damper on that or something? Because it's all very useful and everything, but I think that it's diverting precious attention to what's already amazing and great. You know what I mean?
I'm not quite sure what you mean by throwing
That wasn't a question. That was more of a comment, right?
I'm not quite sure what you mean by throwing every JavaScript library into the cell. I mean, there's quite a lot of JavaScript libraries that we depend on, and I don't think we're particularly planning to reduce those. User code can obviously display stuff using D3 and whatever other libraries it wants, and I'm not aware that that's a problem.
I think it's also more of a usage issue. It's sort of how people, we make a tool and how people choose to use that tool or add on to that tool. We sort of, that's up to the community, right? So I think what you're commenting on is people are finding themselves grabbing Raphael and grabbing all these different libraries, D3 and different things. And for some things, things will stabilize, like MPL D3 will be maybe one of the solutions, or Vincent or something like that. So it's just we're in this exciting period where there's an embarrassment of riches in the sort of things that we can do, and it's not clear what are the right things to do. So we're just gonna let entropy figure it out and just and turn up the heat, right? That's what we can do. That's what you can do.
So I'm curious, with all these other languages developing kind of front ends using the IPython architecture, are you seeing any fragmentation where you get 3 different attempts to make an R notebook, and then people are having to figure out which one they should be using?
Not so far. So far, I'm not aware of any language, but there is one other kernel written in Python, which is it's called simple kernel, and that's purely as an example for people wanting to write other kernels. Other than that, I'm not aware of any languages where more than one person has tried to implement a kernel, and we maintain a list on our wiki of the different kernels that are available, so there's an easy place to go to see if somebody's already written it for your language.
But Chris, for example, that was the case for the Haskell kernel. The iHaskell kernel that Thomas demonstrated is actually a re-implementation of a Haskell kernel that somebody else threw together and then sort of left hanging and didn't quite finish, didn't quite fit all the right parts, and someone else came along and picked it up and started a new project altogether. And so there is some fragmentation, but again, it's one of those things that the ones that last, the ones that people really put time in, those are the ones that tend to stick. If there's no, oh yeah, here we go.
Is there documentation on how to integrate new kernels, like on the IPython website? And then the second thing is the bipython that you showed is particularly just scrolling through the doc strings part of it is pretty interesting. Is there a plan for that to come into IPython at some point?
You want to take the first part of it?
Yes. So in terms of creating new kernels, the useful starting points are this is on the IPython wiki the page called Projects Using IPython. It has the list of kernels. So there's a blog post by the creator of the iHaskell kernel, which a lot of people have found useful. The simple kernel by the author of the Calico project is a very useful example. And this document is the IPython messaging spec. So this tells you like all the different bits of JSON that are passed back and forth. So that's a really valuable document, and it includes up at the top, details of the messaging pattern and the wire format that the messages are serialized into.
As for the second part of the question, so the bipython sort of tabbing through completions and getting the doc string, that's definitely something that's doable. I'd like it in the notebook, but I have to, we have to work with other developers and what they think. It's not my I mean, the reason that I was able to do that in bipython is because I wrote it. So I get to decide. I get to make decisions on it. I don't get to make decisions on IPython, unilaterally, right? So we have to. It's something we have to hash out. And I'm looking at Brian because Brian's a big brains behind a lot of this stuff. So it's something that it's possible, and it's definitely possible as an extension. We've added, especially in IPython 2.0, a lot of things that where you can decide what the different key bindings do. And so maybe you'll weaponize your tab key differently than is in the built-in that comes shipped out of the box.
Yeah, one of the things we keep trying to emphasize is like there's a million and one things that would be really awesome if we just did X, and we're desperately trying to encourage people, go and do X without us.
You can.
We can't integrate everything under the sun, so we're trying to add lots of like extension points and these mechanisms for different kernels and things, and that includes in the front ends.
All right. So, there's another one.
Real simple question. How do you tell what version of IPython you're running?
How do you tell what version of IPython you're running? You go IPython. Oh, there's my demo. You go import IPython, IPython.sys version, sys, what? Sysinfo, sorry, sys version, sorry. Oh, and then you have to print it.
If you don't customize your prompt, you just type IPython and it tells you.
Oh yeah, that's right. That's right. Well, I mean, but who does that? Who does that? I want to switch back, not to have a switching back battle, but so that's Thomas is referring. That's my prompt when I launch IPython. But I wanted to show you because we have 2 more minutes. Thank you for your questions. Something that I just spent more time on. So this is like double diamond territory. So feel free to tune out. It's sort of this isn't a bunny slope. But to extend the analogy for ICCP and HTTP. You can think of the notebook server is actually, the IPython notebook server is actually, you can think of it as kind of a proxy where between your web browser, on the JavaScript in your web browser and the notebook server, we speak ICCP over WebSockets, okay? And then on our behalf, on the client's behalf, the notebook server instantiates a kernel and speaks to it using 0MQ. Now that also means, and some of you may already take advantage of this possibility, you can get a direct route to that kernel using any of the other clients that's not the notebook client, right? And so I just drew a little sort of sequence diagram of the sort of thing that happens is the notebook server first initiates a kernel, starts it up, and sends you the IPython notebook file, JSON file that you requested. The JavaScript in your browser interprets it. Then the user types in x = 1, presses Shift-Enter or Control-Enter. That sends an execute request, and the in prompt goes to a star.
Somehow the code turns from x = 1 to x
x
= 42.
Oh, that's right. Yeah. So there's a bug in here. I wrote this very late last night. It becomes 42. It's the meaning of life. Execute 42 goes then to the kernel. The kernel does its thing to do execute 42. That's a valid Python statement. So it says, OK, and the execute count was 1. This is the first statement that you ran. So that it'll say in the message execute count 1. execute count 1 and OK message is sent back to your JavaScript that's running in your browser, and then your browser updates your in prompt to be, oh, this was in 1, and there was no out because x equals 42 or 1, depending on which one you take, is just an assignment operation, so there's no out 1 for that. And with that, oh,
Look at that, on the dot.
So I actually have a quick question.
Oh.
So
You ruined that.
You ruined it.
that's okay because I can control the clock.
Oh, that's
so,
right. Okay.
Add a minute to the clock.
He's added 2 minutes. 2 minutes.
The Lisp community and the Emacs community have done a lot of this sort of,
Yeah.
you know, I have this server running and I interact with it with various Emacs or things. Like people have done this sort of thing in other communities before with much less sexiness, granted. But is there any communication back and forth, or is there any interaction?
Between us and the Lisp community?
Or the idea is passing back and forth? Yeah.
I'm not aware of it, except to know that some Emacs user
Right.
or Emacs users in general have used it. So they've re-implemented they don't use any of our IPython Notebook JavaScript front end. They've re-implemented all of that. There's a Lisp or Scheme or whatever Emacs uses WebSockets implementation that they use to speak ICCP to our web server. So so there are crazy people out there, but I don't know that I don't know that the community is.
And we should say this is called Emacs IPython Notebook.
Yeah,
if you want to go and search for it.
I've pulled it
Oh,
up
yes.
here, and there's a link to it in the talk. Yeah.
There's certainly lots of crazy people out there. Okay, let's give Thomas and Paul a round of applause.
Okay. Oh, I have stickers. We have stickers if you
And
want.
they have stickers.
Yeah.
And then there's a break for food. If you want to go that way, that'd be great. Or come up here and shower them with accolades.